Given this fraction of trig functions, and we're asked to differentiate it. So we're going to be using the quotient rule. Now, one thing in the final answer is sine 2 theta. So it's worth just making a note of what that is. I'd say to learn the fact that it's 2 sine theta cos theta. Because then whenever you see sine theta cos theta, you're ready to potentially replace it by a half sine 2 theta. For example, if you're asked to integrate sine theta cos theta. If you don't know it, you can actually get away with it in this question. You just go look at the addition formulae, change it look at the plus one, replace b by a, and we'll get sine 2a is sine a cos a plus cos a sine a, which is 2 sine a cos a, which again takes us to here if we replace a by theta. We're also given the quotient rule. I always use u and v instead, so I am going to replace them here. So u dash v minus uv dash over v squared. I've got u, I've got v, u dash, sine goes to cos when you differentiate, so we're going to get 3 cos theta, no further explanation of that. V dash is going to be 2 cos theta for similar reasons, but then cos goes to minus sine, so it's minus 2 sine theta. That means dy by d theta is going to be u dash, that's my 3 cos theta, times v, 2 sine theta plus 2 cos theta, and then minus u, which is my 3 sine theta, times v dash, 2 cos theta minus 2 sine theta. We're going to need to do a fair bit of simplifying here. All over 2 sine theta plus 2 cos theta squared. Now, what I could do is factorize out the 2. And then just square them separately. I think that'll make life a little bit easier in the long run. If you don't do that, you'll still be okay. Okay, let's multiply out this bracket. So I'm going to get 6 sine theta cos theta, and then 6 cos squared theta, minus 6 sine theta cos theta. Actually, these two are going to cancel. Then plus 6 sine squared theta. On the bottom, I've got 4. This is a double bracket. I'm going to get sine times sine. So sine squared theta. I'm going to get cos times cos. And I'm going to get sine times cos twice. And I do want to, I've got the answer in mind here. I can see in a minute we're going to replace sine squared plus cos squared theta by 1. So I'm actually going to, this is going to become 1. And we're well on our way to being able to do this. I can also factorize out a 6 from the top. And I'm going to get sine squared theta plus cos squared theta. So that's also going to become 1. Right, so I'm just going to put a line for it now and say it's 1. And then I'm going to be left with 4, 1 plus 2 sine theta cos theta. Actually, we're very nearly there because this is going to, the 6 and the 4 just becomes 3 over 2. So 3 over 2, 1 plus sine 2 theta. Remember at the start, that's what I said sine 2 theta was. And the final answer they've asked us to write it is a over 1 plus sine 2 theta. So I've just got that 2. You can imagine dividing top and bottom by 2. We're actually going to get 3 over 2 over 1 plus sine 2 theta. That is our final answer for dy by d theta when written in the form. We don't actually need to say that a is 3 over 2. It's implied by our answer here.